last video we looked at the 4 patterns that you'll be studying, and then we just started to look at the very first one, which is linear or arithmetic, and we looked at the general term of that. So maybe if you want to practice a few questions from your book, I'd be on page 202, and I would do, no, not all of them, but like maybe 1 from 4 to 6, and 1 or 2 of those, and then 10 is a good one just to generally check how you're finding what we've done so far. So I'll make sure you can see it there in full in case you don't have your book. So what is the point in having the general term? So beyond the general term is 2n plus 1. Well, you can find any term once you know the general term. So t1, that gives me 3, t2, gives me 5, t3, that gives me 7, and I can see that we have a linear pattern. Now I know it's linear maybe from looking at this, because if you link this to your functions or your algebra, if you were to graph this function, it would be a line. So it all kind of links up eventually. So we have a linear pattern, and common difference is 2. And I guess generally that is the best thing about having it, is that you can find out any part of the pattern that you want. But the other good thing about having your general term is that you're able to prove that the full sequence is linear. Now, what do I mean by that? It's very important to understand the word prove. When I talk to some of the first years, they don't understand that if you want to prove the 3 angles of a triangle add up to 180 degrees, they'll just get a triangle, measure the angles, and think, yeah, well, if it worked for this one, it'll work for everyone. Or if it worked for these 10 that I've checked out, it'll work for any of them. But the idea of prove is that every single triangle in the whole world that you could possibly think of, you know it will add up to, the 3 angles will add up to 180 degrees. So even though I've looked at the sequence and I've shown myself that it seems to be a linear sequence and that probably will continue on like that, to prove it requires algebra, because no matter the value of n, so if we did t1 and t2, you know, I'll get a common difference of 2. If we did t3 and t4, t3t and t2, whatever, I'll get a common difference of 2. But no matter the value of n, that's how we prove something, that we leave n blank or as a variable, and then we try and prove it. So what do I know about a linear sequence? I know that any term, when I subtract the previous term, in this situation I should get 2. So if I say that in a very general way, any term minus the previous term in this particular situation should give me the answer 2. Now I'm hoping that when I do the question, it's just, how do I go about this? Well, I have Tn, and I want to subtract Tn minus 1. Well, this is kind of where your substitution in algebra or your functions come in. That if that's Tn, if I want T1, anywhere I have an n, I put in a 1. If I want T5, anywhere I have an n, I put in a 5. If I want Tn minus 1, anywhere I have an n, I should be putting in a 1. So if I want Tn minus 1, anywhere I have an n, I should be putting in an n minus 1. And then just clean that up, 2n minus 2 plus 1, that's 2n minus 1. So Tn minus Tn minus 1 That gives me 2, which proves that no matter the value of n, when I get any term and subtract the previous one, I get the answer 2. So the whole sequence is linear, and that's proving it. You could try a few. So maybe if you want to check and see if that one is linear. Or there's a question in your book on page 203, and you can check if some of them are linear. Question 12. Not all of them are linear, but some of them are linear. You'll probably even know by looking at the general term, if you link it to your algebra and functions, if it's linear or not. But it's about proving that it's linear, if you think it is linear. And then what you might try is a really good question on page 203. Again, it's question 16. Try not to look back at any example, but if you get stuck, let me know and I can help. Or you can look back at an example if you can find one on it, and then when you go on to the next page, there's a few more there similar to 16, so if you need to practice it. And then I would try 19, 20, 21, maybe one of those or two of those, and should be okay with that then, if you're happy with those. The next thing that you can do then is, I guess you might not want to know this, but I'll just do it anyway, just in case you'd like to know the ins and outs of everything that you're doing. If you want to figure out where the general term formula comes from, now this is not a necessity at all to understand. It's just if you want to know where it comes out of. I'll just quickly run through it. Otherwise, just press pause or stop the video and skip on. So if you think about it, your first term we call A, which means my second term is A plus my common difference. My third term is A plus 2 times my common difference. My fourth term is A plus 3 times my common difference, and so on. So that's my first term, that's my second, that's my third, that's my fourth. And if you look at it, when it's your first term, you add on 0d, 0 times the common difference. If it's my second term, you'll add on, this plus 1d. If it's my third term, it's this plus 2d. If it's my fourth term, it's this plus 3d. So when you think about it, hopefully you might see the pattern there, that if it's my nth term, well then it'll be this plus n minus 1 times d. And that's where the formula comes out of. That's it, I think, with all that.